Hello everybody and welcome to my channel Saranga Tutorials. Now in this new video, in the latest video, we are going to discuss the requirement elicitation step for one very interesting ADAS feature, driver monitoring system. Alright, here we go. Now the driver monitoring system is critical ADAS feature designed to assess the driver's state in real time, including attention, fatigue, drowsiness, distraction or impairment. It ensures safety by warning the driver or triggering interventions like slowing down the vehicle or visual reminders or some kind of audible reminders if risky behavior is detected. Now it is a common knowledge that distracted driver can be a very important reason for any accident. Keeping that in mind, this feature has been developed. The requirement elicitation step is the foundations of developing driver monitoring system or DMS, the acronym, and henceforth I'll be using the same acronym as it identifies and formalizes what system must achieve based on stakeholder needs, safety regulations, and technical constraints. Now, talking about the required elicitation step for the actual DMS, first is stakeholder identification. We have to identify all the stakeholders, all the parties of interest in the elicitation process. So the most important stakeholder, of course, is the OEM and the tier one supplier, and you have to identify the business goals, the differentiation, the cost, and integration. Now, talking about the regulatory bodies like UNECE, R515, R157, Euro NCAP, NHT, GSR 2024 mandates, and end users. Okay, end users means the drivers, the fleet owners. Sometimes even their input becomes an extremely important input. And of course, the development engineers like system engineers and developers who take care of the feasibility, the hardware and software limitations. Next is once you identify the stakeholders, next you take care of the use case. All right, elicit requirements by mapping real world situations where DMS is essential. Now talking about the drowsiness detection, drivers eyelids drooping, head nodding. So this is one important use case because especially in long drives, especially on highways, sometimes the driver may fall asleep. So if at all the driver's eyelids are drooping and head is nodding, then drowsiness is detected. Next is distraction. Something like he's again using the phone, or something like he's again concentrating on infotainment. So that is recorded or considered or interpreted as distraction. If the driver is again looking away from the road, then it is considered as distraction. Now talking about cognitive load monitoring, rapid gauge shifts, confusion, stress. All right. Next is impairment detection, erratic movements, abnormal reaction times. Hands-on wheel detection if integrated with steering torque sensors. So these are all the various types of use cases that must be defined first. Next, talking about the regulatory and safety standards alignment. During elicitation, the team must align requirements with Euro NCAP 2025 roadmap, which mandates the distraction and drowsiness monitoring. Okay, so this is not a bell and whistle additional feature anymore. According to some regulations, driver monitoring system is a mandated feature. Now something like UN R151 and R157 regulations for driver attentiveness in automated functions. Also, ISO 21448, which governs the SOTIF, safety of the intended functionality. Safety of the intended functionality important for avoiding false alarms. So GDPR and data privacy laws, handling of camera-based driver data securely. Now, talking about the functional requirements capture, through workshops, interviews, and analysis, functional expectations are extracted. The system must detect eyelid closure late. Okay, this is very important because based on this only the system detects whether the driver is drowsing or he is perfectly alert. All right, so he must detect the eyelid closure rate and blinking frequency. The system must monitor head pose, gaze direction, and yawning events. All right, driver is again and again yawning, the system will monitor and identify. The system must classify driver state, alert, distracted, drowsing, and impaired in the real time. The system must alert triggers like audio, haptic, and visual when unsafe conditions are detected. This is extremely important. Actually, this is the very purpose of the driver monitoring system. The system must interface with other features like adaptive cruise control, lane keeping assist, and automatic emergency braking. All right. Now, talking about the non-functional requirements capture, Elicitation also identifies performance, usability, and system constraints. All right. Now, talking about the accuracy and reliability, it must be greater than 95% detection accuracy under varied lighting conditions. Latency, alerts within less than 1 second of detecting drowsiness. Robustness operates in different driver demographics, age, gender, glasses, and beards. Okay, so this non-functional requirement must be capable of capturing all the various features, even whether the driver is having spectacles, even what is the gender of the driver, whether it is having a beard or whether it is some, as per some religions, they may wear some mask or something like a burqa. All these things it must clearly cover. Now, talking about the environment resilience, it should work in daytime, during snow, during rain, or during hot sunlight where there's a glare which is radiating directly from the road. All these various environments, it should work with perfect resilience. And next is, of course, the privacy and security. Biometric data not stored, shared without consent. All right. Now, next is interface and integration requirements. Must integrate with cabin cameras, steering sensors, and seat sensors. All right, and it must also exchange information with CAN bus, Ethernet backbone for other ECUs. It must comply with human-machine interface guidelines so alerts don't overwhelm the driver. Now, there are some clear-cut interfaces because alerts should not overwhelm the driver. Instead of becoming a warning, it should not become a nuisance. It should not become a kind of distraction for the driver. Okay, so there are some clear-cut HMI guidelines, and also it must support the over-the-air updates for algorithm improvements. All right, so these are the interface and integration requirements. Now, talking about the conflict resolution and prioritization, OEM may want low-cost infrared cameras, while Tier 1s suggest higher resolution trade-offs. All right, so these kind of back and forth, or these kind of discussions or difference of opinions may sometimes happen between OEM and Tier 1s, which must be resolved at the beginning itself. All right, so there must be a proper balance between, or rather a trade-off between false positives and false negatives, and prioritize safety critical requirements over optional features. Now, talking about the documentation and validation of requirements, documented in software requirement specification and system requirement specification. Now, traceability ensured via requirement management tools, and requirements are validated with stakeholders and mapped to test cases. All right, so these are the documentation validation requirements. Now, example, the requirement statement for DMS. Let's see some live examples or problem statements for driver monitoring systems. The DMS shall detect eye closure longer than 2 seconds as drowsiness indicator. Now, in case the driver closed his eye for more than 2 seconds, immediately the DMS will identify or become alert that the driver is falling drowsy. The DMS shall generate a visual or an acoustic alert within 1 second of detecting driver distraction exceeding 3 seconds. So the minimum duration of the driver monitoring system warning is 3 seconds, so that the driver becomes alert. And the DMS shall function in a cabin lighting ranging from 1 lux to 30,000 lux. 1 lux means night driving, and 30,000 lux means direct sunlight. All right, the DMS shall not record or transmit facial images with it without explicit user consent. Let's extend the requirement elicitation for driver monitoring system and map it into V model development process, which is widely used in ADAS development for ensuring traceability, safety, and validation. All right. Now talking about the requirement elicitation, the V model mapping for DMS. Now we will see uh, in the perspective of V model mapping for or the V model development for driver monitoring system, how the requirement elicitation is happening. All right. Now, first is left side is decomposition from stakeholders' needs, system and software design, and right side is integration and testing, and from unit testing, integration, system validation, requirement elicitation forms the top left entry point and drives the entire flow. Okay. Now, first step in, or rather, the top left of the V model is first is elicitation outcome. Stakeholder needs. I will not go detail into this because we already discussed who are all the stakeholders. So, stakeholders needs like drowsiness detection, complying with the various norms, and functional and non-functional requirements, accuracy, latency, privacy. All right. Now, interface requirements, camera, HMI, and CAN. Now, talking about the mapping in V model, documented in system requirement specification, traceability ensured via tools, and linked to acceptance test cases on the right side. This is extremely important because this is what dictates the traceability. Now, talking about the system architecture design, the first of all, when you decompose, you translate the elicited requirements into system blocks, and when it comes to sensor, infrared camera, steering angle sensors, seat occupancy, all these sensors must be working at their utmost efficacy. And talking about the ECU, DMS ECU or integration into cockpit domain controller or HMI, display cluster or audio alerts, haptic reminders, all these things are extremely important. All right. Now talking about the software and hardware requirements. The algorithms for eye blink detection, gauge estimation, and head pose tracking. AI and ML models for driver state classification. All right. Now talking about the hardware, camera placement, processing unit. These are extremely important. All right. These are all the software and the hardware requirements that must be taken into consideration without fail. Okay, I can emphasize in words the importance of this. Next is non-functional requirements like latency, the lighting conditions. These also should be considered. Now talking about the component design and implementation, software modules, face detection, eye tracking, state estimation, decision logic, alert generator. These are all the various parts of the software modules. And talking about the hardware modules, camera module, ECU processing unit, HMI actuators, requirement map, these are the hardware modules in the correct working workflow order. And talking about the requirement mapping, each requirement links to component responsibility. Now, talking about the unit and integration testing, unit testing, eye closure, when it comes to eye closure detection, algorithm tested with data sets, head pose tracking valid under controlled conditions. So under unit test itself, these two applications can be tested. Now talking about the integration testing, ECU plus camera integration tested inside the vehicle, check timing constraints latency less than 1 second, and verify alerts triggered only under valid conditions. All right. So these are the when it comes to unit and integration testing, this immediately we are transferred to the right side of the V model. Now talking about the system verification, each LCD requirement, each derived requirement is mapped to a test case. Okay, first test case or use case is detect drowsiness by Perclose, which is a eyelid detection software. If at all it is greater than 40% for 1 minute, immediately test is simulated drowsy driver scenario with recorded data sets. Okay, this is an important requirement. All right, and I repeat this and follow this very carefully. So with the help of this drowsiness detection software named Perclose, you detect greater than 40% for 1 minute for 40% of the time duration if you are detecting drowsiness. For that scenario, you simulate driver drowsy scenario. All right. Next, when it comes to alert within 1 second of distraction greater than 3 seconds, driver looks at infotainment for 5 seconds in day-night conditions, and verification ensures system meets technical specifications before validation. Validation right top of V. End-to-end requirement of validation conducted with real drivers, multiple demographics, varied road and light conditions. All right, this falls under validation. Now compliance checked against these norms, these Euro NCAP DMS norms, UN regulations, OEM safety goals, stakeholder acceptance confirmed. All right. Now talking about the test fleet logs show greater than 95% correct drowsiness detection under highway driving, and it also demands that requirement is validated. Okay, so hope all of you are getting a clear idea about the right side of the V model. Now talking about the visual flow, a simplified V model with DMS example. First, stakeholder needs, next system requirements, next the architecture, next the software and hardware design, and next is implementation. All right. Now again, when it comes to right side, unit testing, integration, system verification, system validation, and stakeholder acceptance. So hope all of you got a clear-cut idea about the step-by-step development, both on the left side and the right side of the V model for driver monitoring system. Now, in summary, requirement elicitation for DMS sets foundation at the top left of the V model, and every step down the left side refines those requirements into design and implementation. On the right side, each requirement is verified and validated, ensuring safety, performance, and compliance before deployment. So to elaborate further, requirement elicitation for driver monitoring system is multidiscipline, regulation driven, and user focused progress. It ensures that DMS not only detects unsafe driver states accurately, but also integrates seamlessly with other ADAS functions, respects privacy, and complies with global safety regulations. Okay, so hope all of you got a clear-cut idea about the elicitation of the DMS model. And in case you are more interested about learning A to Z of ADAS, I am very happy to offer you a course which I have designed and developed. I repeat, which I personally designed and developed. The course name is Fundamentals of ADAS, which is available in this website, sarangatutorials.com. This same link I have given in the description also. You are most welcome to click on the link and go directly to the website and buy the course. Buy the course. And let me tell you that course is certified. As you can see here, this is the template or the format of the certificate which you will receive once you complete the course. All right. So thank you so much. So in case you want to receive notifications about further such videos, please subscribe and press the bell button. And in case you like this video, please press the like button. Your pressing the like encourages me. So all the best, good luck, and thank you.